Okay, we're picking up with Unit 2, Lesson 13, and we're starting with Example 4. So we have a word problem here. It's about distance and swimming. It says Lilia swims for 5 hours in a stream that has a current of 1 mile per hour. She leaves her dock and swims upstream for 2 miles and then back to her dock. What is her swimming speed in still water? So the first thing we have to think about is that we're given the speed of the current in the stream. So we know the distance that she swims upstream, and then we know the total time that it takes her, because it takes her 5 total hours. So using that information, we need to come up with an equation to model the situation for distance. And anytime you have distance and you have a speed that something is traveling at and a time, you need to use the equation distance equals rate times time. Or you can solve for time and have time be distance divided by rate. So we're going to apply the information from the problem into this formula on the next screen. So we're going to call R whatever her speed would be in still water. So that if she's going with the current, so the current was 1 mile per hour, that would be R plus 1. And her speed against the current would be R minus 1. So her time with the current would be 2 over r minus 1 because that's distance over rate, and we know the distance was 2 miles. And her time against the current would be 2 over r plus 1, and we need to add those two trips together to get the total time. So basically we have this equation right here that we're going to need to solve. So we're going to need to get a common denominator, and then it's just pretty much like the other examples we've already looked at. So our common denominator, if we multiply r minus 1 times r plus 1 together, we get r squared minus 1. So we're going to multiply every term in the problem by that common denominator. And when we do that, our problem is going to simplify down to 2 times r plus 1 plus 2 times r minus 1 equals 5 times r squared minus 1. We're going to distribute that stuff out. We're going to combine our like terms. We're going to get all the variables on one side of the equation, and we're left with 5r squared minus 4 minus 5 equals 0. And then this is just a simple quadratic equation which we can factor and find the answers to. Okay, so we see here that we can't actually factor that problem. If you tried, you wouldn't be able to find any numbers that worked out. So we have to use the quadratic formula. So we're just throwing the a, b, and c values in. We plug them into the quadratic formula. We're going to simplify all that down, and we get the answer 2 plus or minus the square root of 29 over 5. For the purpose of this problem, like this is the exact answer, but that doesn't really mean very much to you in terms of numerical answers. So I'm going to just type that in my calculator off the screen real quick and see what that comes out to be. So 2 plus the root 29 over 5 is 1.477. So we're going to say R equals 1.477. And 2 minus root 29 divided by 5 is negative 0.677. And hopefully you remember that you can't move at a negative rate. Sorry, that negative sign should be down here. Let's see if I can move it over. Okay, there we go. So the only answer that's applicable for us is the 1.477. Okay, they actually did it over here. So since speed must be positive, the answer is about 1.5 miles per hour that their rate is in the water if there's no current, when it's still water. We're just going to check our answer real quick, throw 1.5 back in the problem. When you do that, you simplify down and you're going to get 4.8, which is close enough to 5 that it's acceptable, because we have to remember that we rounded our answer to get 1.5. So our exact answer on this left side is not going to come out to be exactly 5 since we rounded up here to get 1.5. All right, check your progress problem for example 4. Read through this. pause the video, work it out, and when you have your answer, go on to the next screen. Okay, our answer for problem 4 is D, 6.6 miles per hour. Okay, another word problem, example 5. This is about mowing lawns. It says Wuyi and Uema. Man, those are some difficult names for me to pronounce. I have no idea if I said those correctly. Wuyi and Uema mow lawns together. Wuyi, working alone, could complete a particular job in 4.5 hours, and Uema could complete it alone in 3.7 hours. How long does it take to complete the job when they work together? So our plan for this, we know that Wuyi can mow the lawn in 4.5 hours, so her rate is 1 over 4.5 of the lawn per hour. Similarly, Uema can mow the lawn in 3.7 hours, so her rate is 1 over 3.7 of the lawn per hour, and their combined rate is 1 over x. The reason we're using 1 is because we're figuring out what they can do in 1 hour. So we have Uema's rate is 1 over 3.7, and Wuyi's rate is 1 over 4.5. The combined rate is 1 over x. So to solve it, we just have 1 over 4.5 plus 1 over 3.7. If you combine those, you get 164 over 333. We're going to cross multiply, and we get x is 2.0304 about. And so that tells us that when they work together, it takes them about 2 hours to mow the lawn. So obviously they get the job done a whole lot faster because it takes one of them 4.5 hours by themselves. The other one takes 3.7 hours by themselves. But if they work together, they get the job done in only a little bit over 2 hours. We're going to check our answer by throwing the answer of about 2 in here. When you add these together, you get pretty much a half over here. So it checks out. We'll make sure that our answer of 2 hours is correct. Here's another check your progress problem. Read through this, pause the video, work it out, and you have your answer going to the next screen. And our answer this time is C, 2 hours and 45 minutes. Okay, the last thing we're going to look at in this lesson is how to solve a rational inequality. Here's some steps that we need to go through. The first one is stating excluded values, and that means values for when the denominator of the fraction is 0. We're going to need to solve a related equation. We're going to use the values determined from previous steps to divide a number line into intervals and then test the value within each interval to determine which intervals contain values that satisfy the inequality. So our first problem says 1 over 3k plus 2 over 9k is less than 2/3. So the first thing we're going to look at is when the denominator would equal 0. And obviously, when k is 0, these denominators would be 0. So we have to exclude the value of 0. We're going to step 2 is solving the related equation. So basically, we're going to take this problem and turn the inequality into an equal sign and solve the problem. So we need our common denominator, just like we looked at earlier in the previous examples. Our common denominator would be 9k. When we multiply the problem by that, it simplifies down to 5 equals 6k, which means k is 5 over 6. Step 3, we're going to draw vertical lines at the excluded value and at the solution to separate the number line into regions. So we have a vertical line at the excluded point 0 and a vertical line at 5/6, which was our answer for k. Well, now what we're going to do is test a sample value in each region to figure out what the signs of the answers in that region would be. So we have to pick something to the left of the first line, something in between there, and then something to the right. So first we're going to pick k as -1, which is to the left of 0. When we plug that in, and we simplify everything down, we get -5/9 less than 2/3. That is true. When you get a true inequality at the end, that means that 0, anything less than 0, anything to the left of that first dotted vertical line, would be a solution. Next, we're going to test a value in the middle of that section between 0 and 5/6. When we plug that in, we get down to 5/3 less than 2/3, which is not true. So anything between 0 and 5/6 is not a solution. Finally, we're going to test a value to the right of the second dotted vertical line. And when we plug that number in, we're choosing 1. We get 5/9 less than 2/3, which is true, which means that anything greater than 5/6 is a solution. So our final answer would be that the solution for k values for this problem is anything less than 0 or greater than 5/6. Okay, we're looking at the check your progress for example 6. We have to solve this equation 1 over x plus 3 over 5x is less than 2/5. So pause the video as long as you need, work out the problem, solve it the exact same way as we looked at for just example 6 in the previous one, and have your answer go into the next screen. Alright, the answer for check your progress number 6, C, x is less than 0 or greater than 4, are the correct answers. Okay, that brings us to the end of Unit 2, Lesson 13 on solving rational equations and inequalities.